Hi everyone, welcome to Farm Sci-Ed, the show where we go into the science and education behind farming. I'm Emily Stein, and today I'll be talking to Dr. Jeff Bradshaw, entomologist, at the Panhandle Research and Extension Center. We'll be discussing his research on the relay system that he's been working on with wheat and dry edible beans. So sit back, relax, and let's go check out what he's been up to. So Jeff, can you explain to me what a relay cropping system is?
So a relay cropping system is a method of intercropping where you have one crop that's planted into an existing crop. And particularly in our case, we're looking at a cereal, a winter cereal, winter wheat, and then we plant dry beans into it, a legume, in the spring. So the existing crop is then harvested first. So winter wheat would be harvested before dry beans, and we'll harvest that off the top of the dry bean canopy essentially. And then we'll come back in September and harvest those dry beans. So typically in these situations, we have oftentimes a legume is planted into a cereal crop where you see these types of relay crop intercropping systems. And part of that is because of they're different plants, so they don't share necessarily the same diseases or pests or even weed control technologies and strategies.
And how does this differ from a cover crop?
Yeah, it does share some similarities with a cover crop. Some of the benefits of a cover crop, as the name implies, is to provide cover at a time of the year where there normally wouldn't be, right? As opposed to just bare ground, bare soil that would have the potential to blow or to lose moisture and lose some of the other benefits that a cover crop can provide, including weed competition, basically, by having that cover present. The way that the relay cropping system is different than a cover crop is that you're actually running that early crop out to harvest. So that makes it different. And then in our case, there's timing of the crop that coincides with some kind of key pest development throughout the season, as well as provide some benefits to the natural enemies that are in the environment. So if we, for example, have that relay cropping system established early, similar to a cover crop, but then as it matures, those natural enemies that are conserved in that relay cropping system can then immigrate out of that cereal and into the legumes at a time, in our case, that would hopefully coincide with when pests become more active. And so now those predators can be available to attack those pests. That's the strategy anyway.
So when you're growing in a relay system, what compromises do you have to make?
Yeah, so there certainly are compromises, as there are in many cases in agricultural actions. So there is the possibility of reduced yield. So we've got, competition between the two crops on any given plot of land when we're looking at that relay system. So they compete for really all the inputs that go to making a plant grow. So there's competition with water, soil moisture, for example. There's competition for nutrients, competition with light. And so all those become a factor to consider in this relay cropping system that could be trade-offs that need to be explored. And so ultimately what we're doing is trying to look at what would the balance of those trade-offs be, and from a whole cropping system perspective, are the trade-offs worthwhile because they bring some other benefit down the line, meet some other goals for the land manager and the agriculturalist or the producer.
Are there other benefits this wheat and dry edible bean system provide?
Yeah, so initially when we thought about this particular cropping system in our conditions out here in western Nebraska, initially, as an entomologist, I have a bug bias, sorry to say, but sorry, not sorry. So, I did think about some of these relationships that have been shown in the literature between, in regards to having a crop present earlier in the season, as I mentioned earlier, how they can help establish natural enemies earlier than they would otherwise be established in the field, and making them available later in the season in higher numbers where they can be more functionally relevant. But importantly, we also thought about the production system and what some, our grower is mostly concerned with yield, the amount of grain that's harvested off a field, and of course the quality of that grain. And so we did in thinking through this, think about the production aspects first. And then it sort of dawns on you as you think about it a little more, like, oh, that's kind of similar to this. Oh, there may be some other side benefits to that. So those would include, and specifically elements when we think about dry bean production here in this part of the world. There's a lot of interest in upright dry beans, and part of that interest is because you can use a direct harvest combine. You don't need the additional equipment or additional passes through a field that you would need with a prostrate bean that's growing along the ground, where you have to cut it and windrow it and then come out and pick it up. So there's these benefits with this direct harvest in terms of streamlining time that a grower spends in the field, harvesting the grain. The trade-off historically with direct harvest is some challenges related to getting the pods high enough off the ground. Get them high enough off the ground where the cutter bar can actually harvest a majority of the grain. So typically we've seen that there can be a lot of variability depending on equipment and production practice and soil topography and so on that can interact with yield loss. But we see somewhere around 10% yield loss in direct harvest beans that are just a matter of the mechanical harvest process. So in a dry bean plant, in the upright morphology, we still see a lot of the dry bean pods hang below the cutter bar, less than 2 inches above the ground, and might even touch the soil surface. So what happens is, as the combine goes through, the cutter bar goes through, it clips all those beans that then can't be taken up into the combine. They just fall, shatter to the ground. So one of the things we thought about in this intercropping relay system was the attributes of the plant to grow a bit taller when it detects infrared light from surrounding plants or has light competition. So a dry bean plant will grow taller. The inner nodes would be longer. And the thought is then those pods would actually be higher above the ground. So that's one other aspect that we're looking at strictly on the agronomic and production side of things to see, okay, now we've got pods that are higher above the ground. So even though if we have these trade-offs with, as I mentioned before, soil moisture or nutrients or light, we may see the benefit of actually recovering more yield because we have a taller bean.
What does your research look like this year?
Yeah, so our aspect of the relay study, so we've got a bug side and a weed side of the study that we're doing. And so on the bug side of things, we're specifically looking at the relationship between, we've got 4 treatments that we're looking at. We've got dry beans only, so we actually rototilled the plot and then planted beans. So really low residue, maybe a very conventional historic type of bean planting from the perspective of soil management, I guess you could say, or residue management. We have the cover crop approach, which is winter wheat terminated around flowering. Really, the wheat is terminated at bean planting. So we plant the beans and we terminate the wheat crop. So basically by the time the beans come up, the wheat's dying back. So that's our cover crop. Then we have a wheat only. So we have plots that are just left as winter wheat. They won't have any beans to try to look at the competition, the wheat competition side of things from just the wheat alone. And then, of course, we've got our relay treatment where in that case we created very small beds for the beans to plant in rows within the wheat and then planted the beans.
And what are you specifically focusing on within entomology and the relay cropping system?
Yeah, so with these 4 treatments, we're looking at specifically biological control and conservation biocontrol. So right now we've got pitfall samples, pitfall traps that we've got out in each of these plots for these treatments, looking at ground beetles and other arthropods that would be roaming across the ground that might be influenced by these different treatments. Specifically looking at beneficial insects in this case. So there may be one management approach that seems to increase the number of functional species groups that are important for weed seed consumption or maybe they're important for predation of pests later in the season. So we're looking at those samples. We also have sticky card samples, sticky card traps that we have in the field to capture any winged insects, whether they be pests or beneficial. And so we're going through those, counting a lot of thrips and aphids, and as well as beneficial insects like big-eyed bugs and so on. Then we're also doing vacuum sampling to, again, capture all the arthropods, pests, and beneficials that are actually within the wheat rows, but then also within the bean rows, even within a treatment. So in our relay treatment, for example, we're taking vacuum samples of the bean rows and then adjacent to those also in. So we're tracking that. We're also taking sweep net samples, and we're counting those. And when I say we, I'm using the royal we. I'm talking about my student, Jeff Cleaver, who's actually doing a lot of the work, as well as a whole host of interns this summer that are doing the hard work of being out in the field in these hot days. But we're also taking flower samples from the wheat and flower samples from the dry beans when they start flowering. And then later this year, we'll collect yield, of course, but then we'll also check the beans for damage from Western bean cutworm specifically. So ultimately, kind of our target scenario, in this case, right now, Western bean cutworm is the key pest of dry beans in this region. And so that's sort of our target pest as to whether or not we think the system is going to work or not from a biocontrol standpoint. In July, we'll have sentinel egg masses that we put out into plots to try to estimate the rate of egg consumption by predators in these systems, to see if the different treatments, whether it's a relay or whatever, to see what the differences are between these treatments relative to Western bean cutworm egg mass consumption. And then we would hope that would then translate to reduced injury in the dry beans and increased yield. And so coming back to what we talked about earlier, about trade-offs, so our hope would be that we'd have a taller bean, so we'd lose less yield. And then because of the system that we've established, we would have more biocontrol. So we should see a higher quality bean. And then historically, we've had to rely on chemical control means to manage Western bean cutworm. So it's a high bar, but one bar we've got with this in terms of a goalpost is to see if we could eliminate or significantly reduce insecticide input into the system. So we may be able to replace that insecticide cost effectively with wheat seed cost. And that wheat seed cost, one would hope, would then, in an ideal world, pay for itself with the grain that you collect off of the wheat crop. So sort of the production side of things, that's kind of how we're seeing it. We see these replacements. And so ultimately, I know that we are anticipating we should see less dry bean yield in the relay system unless we fine-tune it further as the seasons go on. But we would hope that we, again, have a higher quality bean and recover more of that yield and spend less money on insect pest control.
Well, folks, today we've talked to Dr. Jeff Bradshaw about his relay cropping system research, what some of those compromises to be made are, and what his research is specifically looking at within entomology. Come join us next time on Farm Sci-Ed as we go into the science and education behind farming. Be sure to like this video, subscribe, and follow us on Twitter or on our website at farmsci-ed.com for more science and education behind farming. Have a good one.